Hello and welcome to another episode of creating an underwater survival game like Subnautica. This is part 8. We'll be continuing where we last picked up, doing tools. So the first thing I'm going to do is to actually clean up the scene. So as you can see, we have a bunch of items that can be picked up and interacted with. So I'm just going to create a new game object, an empty one. I'm going to call it stuff. And then I'm just going to move all of the items under here. So as you can see, most of the stuff is now under the... So now our hierarchy is much neater. Then the next thing I'm going to do is to address a bug that we have. So as you can see, when I click play, you'll notice that our health is actually sitting at 0, which it's not supposed to. This is because before we forgot to set the health. So if I go to player stats, as you gain player stats, it inherits from health. Health usually sets the current health to max health in Awake, but since we have an Awake here, it's basically overridden. So what we need to do is to add over here, current health equals max health. So now when we click play, you can see our health has been set properly to 100. The next thing I'm going to do is go down to player manager and then player canvas. As you can see, we have a lot of things on our player canvas and most of them are menus. So what I'm actually going to do is to right click, create an empty object. I'm going to call it menus. So as you can see here, our game manager is really messy because there's a ton of different menus on it. And we're only going to be adding more as time goes on. So I'm going to create this object here to manage the menus instead of the game manager. So I'm going to take all of these menus and just put them in here. Next, I'm going to go to Game Manager and I'm just going to copy all of the menus and move them. So we have our inventory. We have our storage manager. And our crafting manager. One more thing we need to do, we need to actually move these menus out and then make sure this is set to stretch to the full screen so that it's the same size as the canvas. And we don't want to change the menu sizes until we set this correctly. Okay, let's test this out. Make sure all the menus are working properly. If I go over our crafting table, oh yeah, as you can see our panel isn't actually working because the event trigger hasn't been set anymore. Since we moved the menus from Game Manager, now we need to do from menus, crafting menu, toggle menu. So now we should be able to work properly. So you can see our storage, it works fine. Our inventory menu, also working. Then our crafting menu. Oh, our crafting menu probably isn't working either because yeah, we've changed it from game object to menu. So now we have to set all of these to menu instead of game manager. So here let's put in the menu game object and toggle category. Make sure all of the button holders are set to the correct one. Yep. Okay, let's play test one more time. If I go to our inventory, no, our crafting system, as you can see, it's working again. Okay, fantastic. Now we can work on adding in the new tools. So this episode we'll be adding in a sea glide, a flashlight, and a scanner. And along with the scanner, we'll be creating the scan info menu. So that's the menu where you'll be able to see all of the items you scanned. We will also be creating a UI for scanning so that whenever you're scanning an item, you'll be able to see what percentage of scan you have done. So first things first, we need to import the sprites and models that we need to create these three items. First of all, I made a sprite for a radial slider, which we'll be using for the scanning UI, and I also made a sprite sheet for the three new objects we'll be adding. So let's go to art, and I'm just going to drag them in. So we're going to set the two of them to be sprite, 2D, and UI. There'll be single images. Well, one of them will be a single images. So here we have a radial slider. We'll be using a radial fill to show and not show the slider. And here we have the sprite sheet. So this one is actually supposed to be multiple. I'll go to sprite editor. So here in the sprite editor, I'm just going to automatically trim it. And we get 3 new sprites. Now we can go and import the 3 models that we'll be using. So I found free models for all 3 items. One of them is a swimming board, the other is a gun, and the last one is a flashlight. So I found these for free on the Unity asset store. You can of course make your own assets or use these. They'll be linked in the article, which will be linked in the description. So let's go to package manager. So if I go over to my assets, and we'll wait for the packages to load. So let's download these assets. So once we've imported all of them, I'm just going to move them over to external assets. So we'll get to them later and create prefabs for them as we create the tools. So in this episode, we're making a scanner, which is very different from other tools. Because it's a scanner, when you need to hold right, it works when you hold right click and it continually increases the scan percentage of an item that you're scanning. This is different from the other tools which only use like one frame of left click to activate, and you can't hold the button to use other tools. Because of this, when developing the game, I had a lot of problems with it. So I actually decided to change some of the code that we already had. Before we jump in, let's reorganize some of the code in the player controller to make it better. So the first thing I wanted to do is to create a region for player movement so that all movement code can be kept in the same region. So here I'm going to take the switch movement code and the swimming or floating code and copy it and also delete it. Then I'm going to go past update and I'm gonna go over here. So you can see here's the code. Look around. I'm gonna create a new region and I'm gonna call it movement functions. If I scroll down, here I'm going to close off the region. Then lastly, I'm going to put those two functions that we copied earlier over here. So here we have switch movement as well as swimming or floating. Oh, oops. We didn't get switch movement. Yeah, so we're just going to copy and paste them into this region. And now that we've done that, we can just minus the region to keep all of the functions neatly. The next thing I wanted to do was to clean up the update function. So if you look here, there's actually a lot of code going on here all at once. So later on, we'll be changing the tool usage code. So I'll explain that later. For now, let's create another region. And I'm going to call them update functions. So here I'm going to be taking the hotbar detection code. I'm just going to copy it, and here I'm going to create a new function. And I'm going to paste the code in here. So now instead of having all of this code here, we can just put in the function. So this keeps our update a lot neater. So we'll leave this debug function as is, as well as this one. And then here, this is all the functions that happen when we left click. So I'm going to copy this code. I'm going to create another function here in the region. So we just paste in the code. Then up here, we replace the code here with that function. So we can minus these update functions. And as you can see, our update is a lot neater now. After that, I'm going to move the storage functions into inventory. So here it just makes more sense to have all of the storage functions and scripts in the inventory menu, in the inventory folder, because storage is just an extension of inventory in the first place. So in the next part of the video, we're going to be working on tools. So previously, when we did tools, we created a tool-based class which had an overridable function, and then in player controller, we would, whenever we hold an item or change the item that we're holding from our hotbar slots, we would set an event to that to that function in the tool-based class, and then invoke it whenever the player left clicks. However, for the scanner, we need to be able to detect whenever we're holding down the mouse button instead of clicking the mouse button. So it's different from the tool-based class. So after thinking about it, I decided to refactor the code in the tool-based class such that the handling of the activating the function is done within the tool-based class itself instead of inside player controller. So let's work on that first. So we need to go into player controller, then we need to scroll down to current hotbar item. So after we refactor the code, we're going to need to be able to detect what is the currently held object so that we know which object is to activate their functions. However, there's a problem with our current hotbar item code, because if we search for the current hotbar item in update, sometimes we'll get will return an error because there is no current scriptable object of the current hotbar item. Like either an item is not being held or the item isn't a tool, then we would return an error instead of getting an item scriptable object. So in order to fix this, I'm going to change this from an item scriptable object to be a hotbar slot. And then I'm gonna delete this line. Instead, we'll check if we're not holding anything. And if we're not holding anything, we'll return null. And then if we are holding something, then we'll just return the hotbar slot. So the reason I'm doing this is because we're going to be using this function later, but we will need to get we won't need the item scriptable object specifically. We'll need something else from it. So we'll get to that later. Now we can refactor the code in our tool base class. So what we want to do now is to create a delegate, which is basically it stores functions. So it's a variable that stores functions. We're going to create a delegate to store the function of each child class, and then we're going to have an update. We're going to detect whether the current tool is this, and then we're going to check for left clicks. Then we'll call the delegate. So first of all, let's create the delegate. So it's a delegate void, and we'll call it tool action. Now we need to create a tool action. So now we don't need these two functions. Instead, we can set the current action in awake. So I'm going to add in an awake. So in awake, we'd want to set the tool action to something, but we would need a default action. In the tool base class, I'm going to create a default action. So here I'm just going to do debug.log tool default action, and then I'll return. Then in awake, we can set it to the action. So of course, we want the child classes to override this awake and then set their own tool actions. So I'm going to make this an internal virtual function. So in all of our tool child classes, we'll just make sure they override the awake. Otherwise, it'll be set to the default action. Now we want an update. So in update, we'll check the current hotbar item and get the current tool. Then we'll check for left clicks or right clicks. We'll check for input.get mouse button down 1, and then we'll do tool action. So we check if it's not null, and then we check if the tool is the same as this. So if this returns true, that means the currently held tool is this class. Then we'll check for get mouse button down 1. So this update will be the same for most of the tools, but in the case of the scanner, we'd want to change this update so that instead of detecting get mouse button down, it would detect get mouse button, which would call continuously for as long as the mouse button was held. So I'm also going to make this an internal virtual function. So most of the child classes won't override this function, but scanner will. This provides us with the flexibility we need that we don't have if we have these functions in PC. Now all we need to do is clean up in player controller to remove the code that we put here before. So first of all, we no longer need the Unity event since the tool functions are handled within the tool base class. So the invoking of the tool functions is handled within the tool base class. So I can delete that. Then over here, I can delete the event. Then if I go back down to update, I can remove the tool usage block here. Then if I head back to interaction functions, if we go back to hold object, we no longer need to add or remove listeners. So we don't need this block here either, or these, since all of that is handled within the tool base class now. We also don't need the tool default action anymore because we have one in the tool base class. Another positive for having this function called from tool base class is we no longer need to worry about calling and invoking use tool when there's no tool being held. Now lastly, we just need to update the other two child classes. So I'm going to go to inventory and then to tools. I'm going to open up deployable. Here, this function, we no longer need it. So I'm just going to copy this. I'm going to store this as a function inside the deployable class. I'm going to paste it here, and then we'll just get the item identifier. So here, instead of the tool, we want the item scriptable object. So yeah, we would get this here. So now I don't need the internal override void for tool functions because that function no longer exists. Instead, we want awake. So we override awake, then we can set tool action to be deploy item. So in the case of deployable, whenever this function is called, the tool in hand definitely has an item scriptable object and a tool base class. So we don't need to worry about this be returning as null or an error. So this is the new way to make tools. So we'll override awake, then update will handle all of the tool usage. So we'll just check if the tool is deployable or not, and then if it is this specific deployable, it will deploy the item when the tool is being used. We need to do the same thing with weapon. So here instead of overriding two functions, we just want to override awake. And then instead of calling attack, we will call tool actions equals attack. So now update will handle attacking as well. So let's see this. If I click play, let's have a look at what happens. So I'm gonna pick up this knife and I'm gonna pick up a fish. So I'm just going to have these in my inventory. So you can see here, the knife still works properly. I can kill fish. Same with the fish, I can deploy them. And as you can see, there were no errors. Now that we've refactored the tools, we can actually start on creating the 3 new tools for this episode. Now let's create the flashlight. So over here in the tools folder, I'm going to create a new C script. I'm going to call it flashlight. So here in flashlight, we would inherit from tool base class. So in our flashlight, what we want to do is to have a reference to a game object called light source. So basically we'll have the prefab be the flashlight model, and then also a child game object that is the light, and then we'll just turn it on and off to toggle the flashlight. Let's just make a reference to the game object. Then let's override awake. We don't need the update. And instead, I'll create a function called toggle light source. So here we'll just set the light source to be the opposite of its current active state. So if it's active, we'll set it as not active. If it's not active, we'll set it as active. We'll just toggle the light source. So the way I'm going to do that, I'm just going to set it to not light source dot active in a hierarchy. So it just sets it to the opposite of whatever it is right now. Then in awake, we can set the tool action. Now we'll want to go back to the Unity and create the light source tool. So I'll just be speeding up this part. So basically we'll create a regular interactable object, set the tag to pick up, add a box collider, a rigid body, add the interactable object, create the item scriptable object, and then add the flashlight script. We'll save that all as a prefab, and then we're good to go. One thing you want to remember to do for every tool that you create is to make sure that its position is set to 0 and that the rotation is correct whenever you equip it. So let's test it this way. So what we would need to do is to go to player, to main character, and then to hand, and then you just drag a copy of it under hand. So as you can see, it's actually backwards. So what we want to do is like rotate it until it's the length that we want. So I'm just going to drag out the game here to see. Rotate it, maybe move it a bit. So now it should point the correct way. And if I turn on the yellow light, well, you can't see it. Well, it's not rendering or anything, but yeah. So this looks about correct. I'm going to copy the position, the transform. So I'm gonna copy the rotation. Yeah, copy rotation, and then I'll set it in our prefab. So now whenever we spawn in a flashlight into our hand, it should be rotated correctly, as you can see. Okay, now we can test the game. So I'm going to pick up the flashlight, I'm gonna put it in my hotbar, and as you can see, we can now toggle the light on and off. So if it's on, if you leave it on, when you change your hotbar, it'll remain on, which is the same as Subnautica, but of course you can just set it to turn off on awake if you want it to turn off every time you equipped it. So that's the flashlight. The next item we're going to create is a Seaglide. So this one is really unique because instead of having a function that happens when you right click it, instead it gives a speed boost. So let's get back to scripts and create the Seaglide script. So in order to apply a speed boost to the move speed, we need to open up our player controller first. So what I'm going to do is to create a system to detect speed boosts, and then it will take every speed boost into account before applying the final speed to you. It will have a base speed for walking or swimming, and then you'll have a swim speed bonus and a walk speed bonus. These two will keep track of what are the current bonuses you have for swimming or walking, and then apply them in the move function. So let's get started. First things first, in player movement, instead of speed, we want to replace them with a set of variables. So we'll have a public float, which is the base speed. So this is your default speed without any bonuses. Then we'll have a private float speed, which will be your final speed after you calculate all the speed bonuses. After that, we'll have two floats, swim speed bonus and walk speed bonus, which will keep track of what are the current speed bonuses you have. Make sure they're set to 0 by default. Also, for future reference, I'm just going to create a reference to the crosshair. So right beneath hotbar, I'm just going to add a reference to the crosshair so that later on, because we'll be needing it for later. Now, the next thing I want to do is to create a new function. So I'm going to go down to the movement region. So all of the movement functions are here. And I'm just going to add a new function. This function will be called check speed boost, and it will basically have a list of conditions, and if these conditions are met, they'll apply the speed boost from them. So during update, in every firmware update, we'll check the speed boost and then check each condition, and if they're met, the speed will be different, and if they're not met, the speed will be the default speed. So at the beginning, we'll reset all of them to 0. Then we will keep a list of conditions of what gives speed boosts. So later on, under swimming conditions, we'll add the speed boost condition for the Seaglide. Next up, we're going to edit the move function. So here in the move function, we'll call check speed boost to get all of the speed boost values. Then, if we are in water, we'll set our speed to base speed plus swim speed bonus. Then, if we're not in water, we'll set our speed to be a base speed plus walk speed bonus. This way, we'll have our speed calculated whether we're in water or on land. So you can, if you want to, you can also do separate base speeds for water and land. Just add another variable to calculate it. But I'm going to keep the base speed to be the same. Now that we've added the speed boost system, we can create the Seaglide. So I'm going back to scripts, and I'm going to inventory and then tools, and I'm going to create a new C script. So we open up the Seaglide. We'll do the same thing as the torch. We'll be inheriting this from tool base class, right? And then the Seaglide is a special case. It won't actually have a tool. Since the Seaglide is a special case, it won't actually have a tool function. So we don't need to override the update or create a function for the tool. And instead, we will have a static float for the Seaglide of what the speed bonus is. So I'm just gonna set the speed bonus to be 3. Sorry, the Seaglide bonus is supposed to be a static bonus. And that's actually it for the Seaglide class. Now if we go back to player controller, we can go down to check speed boost and to swimming conditions. Then here in swimming conditions, I'm just going to check if we're holding an item. And then if we are, we'll check that we're holding a tool. And then if it's a tool, we will check if the type of the tool is a Seaglide. And then if it is, we'll add the Seaglide speed bonus to the swim speed bonus. So now we can save our code and we can build the Seaglide prefab. One more thing that we need to one more bug that we need to fix for the player before we do anything else is that actually accidentally freeze the Y position of the player. So because movement is controlled not by the rigid body but like by transform, we generally want to freeze the position and rotation because that's handled inside the script. So we don't want the rigid body to do this, but we do want the rigid body to handle gravity. So just make sure that the Y is not frozen. So that's everything for the Seaglide. Before we test it out, let's set the player base movement speed to actually 10 instead of 1 because 1 is really, really slow. Yeah, so yeah, let's now test it out. So I'm going to pick up the Seaglide, assign it to my hotbar, equip it. So as you can see, I'm walking at a regular pace. You see, underwater, I'm swimming quite fast, and then if I disable it, you can actually tell I'm swimming slower by a little bit. We can even change this to maybe a 5 to make it more noticeable. So pick up the Seaglide. On land, whether I'm holding it or not, it's the same speed. But if I go into the water, so as you can see, normal water swimming, but if I hold it, you can tell we actually swim faster. Yep. So that's the Seaglide. Okay, so that's all for today's episode. We said earlier we'd be making the scanner, but unfortunately we ran out of time for today, so that will be in the next video, so keep your eyes peeled for that. If you want to support our channel, you can help us by becoming a patron, because this will give you access to project files for all of our tutorials, as well as Patreon exclusive posts on the blog. So any support you give will go a really long way. Right now, we're not making as much money back as we are putting into the content creation. So if you donate, we'll be able to make this a long-term and more sustainable endeavor. See you in the next video.